Good morning. I wasn't kidding about the Uber drivers. Can we go get some Uber drivers so we can fill the seats here? Welcome everyone to the second day of SPS. Looks like an exciting agenda for the rest of the day, so really looking forward to that. But today, and for the next hour, we're going to share our story around this opportunity around this, what we're calling automation leap. But the only way we get there is if we embrace people, process, and technology. But before we do that, I'm going to make sure everyone's awake. Yesterday, I got an opportunity to connect with many of you, and many of you were engineers. So just by show of hands, how many are you a degreed engineer, a professional engineer, you desire to be an engineer? Okay, that's a lot of you. So, as engineers, we love to talk about technology. And when we talk about technology, it's usually about the future. It's usually about what's going to happen. It's the innovations that we get extremely excited about as engineers. But before we look at the future, I want to take a minute and go back in time, and listen and learn from the greatest teacher, which is history. So if we look at some transformational technologies we've seen in the past that have significantly changed society, the first is the printing press. Knowledge was with the elite until the printing press came along, and that went to the masses. And the school systems were formed, and society changed as we know it. The next one's the assembly line. I'm from Detroit, so I'm very passionate about this. Before the assembly line, so the early 1900s, can anyone guess how many people owned vehicles, percentage-wise? Any guesses? 1%. That's right. Very good, Jake. So 1%, think about that. That's like these 5 or 6 people here. That's it. So the rest of you couldn't have Thanksgiving with all your friends and family because you don't own vehicles. But the assembly line changed that, changed production as we know it. It changed manufacturing as we know it, and allowed us to scale production and make vehicles affordable to the masses and literally open roads to everybody. And then, of course, the internet age, which many of us discovered ourselves, not me, I'm quite a bit younger. Many of us discovered ourselves, but the internet instantly gave us data. It gave us connection globally to those. It launched platforms that changed our commerce, that changed communities. So what's really interesting is this next transformational technology, what we're calling AI, embodies all 3 of these things. So we're going to do another survey and make sure you're awake. So thumbs up if yes, for sure. In the middle if it's neutral. If it's down, saying no way. Who thinks AI is that next transformational technology that's going to change our society? Annemarie, what do you think? I think that's a majority.
Wow, that's an overwhelming response. But also there's a bunch of Siemens people in here.
That makes sense. I think we brainwashed them. So
a little bit, I think, yeah.
Yeah, that's definitely we brainwashed them. So, however, most of us have been working in automation for a long time. And working in automation, as you know, is very fixed and rigid. So Annemarie, what are we going to do with this transformational technology? Do we just sprinkle AI on top of automation and we're good to go?
So first of all, I mean, yeah, you said automation is fixed and rigid. I mean, kind of fair, but it has to be, and it's ultimately about, it has to be repeatable. It has to be highly reliable. Ultimately, we're talking about deterministic control here, right? And now there's this fancy new technology with AI coming in that, yeah, we'll talk about the sprinkle on top. It holds this promise to make us more adaptive, to make us more flexible, to move away from fixed, hard-coded control logic and bring in more flexibility. But it's also inherently different from automation because it's not repeatable. It's not exactly reliable. It's definitely not deterministic. So the big question is, how do we bring these 2 worlds together? And then there's a huge promise out there that if we manage to bring the 2 worlds together, eventually we even get to fully autonomous agents that make autonomous decisions. And if we combine it with deterministic control, ultimately we can autonomously set machine set points, write process parameters. So that's kind of scary too. It's also super exciting, but before I get too excited about all these technological leaps that we can make, it's also important, I think, to ground ourselves in why we're doing this. and because ultimately we all want to become more resilient. And I don't think I need to explain to anyone. I mean, we've all been through COVID, we've all been through the tariff situation on why we want to become more resilient.
So that's a pretty cool vision. As you know, whenever we lay out this vision, the question we always get is, what do we do next? And of course, the response we always give is in the context of people, process, and technology. People, because they have to adapt to change, they have to lead the change. The process, because you want to make sure you have the right implementation methodology to reduce risk. And of course, the technology, which Annemarie, of course, is going to dive into next.
So we talked about AI already a little bit, and it's often scary, again, to think about it. Also think about the impact that it has on the workforce. Many people think that it's a threat to our workforce. It's going to definitely change jobs. I mean, we definitely believe that if it's done right, and if it's built right, and if it's built with the people and for the people that we're building, it's going to actually augment our workforce. It's going to make everyone more productive. It's certainly going to change jobs, but we're going to talk about that a little bit. But when speaking of fears, also when it comes to process, we see that there are quite a few fears out there that often paralyze decision makers almost. So we often don't see that we can actually move forward and drive decisions and move towards outcomes. It all starts a little bit with the good old FOMO, right? Fear of missing out. Many of us kind of don't know what is that next step that we should take. Then maybe some of us are afraid to get it wrong. AI, especially generative AI, as we all know, is hallucinating. Maybe we're afraid of kind of getting stuck in the proof of concept land, or maybe afraid of getting stuck with a certain vendor, with a certain technology stack and kind of getting locked in. So what we want to talk about as we talk about accelerating outcomes is really how do we overcome this decision paralysis and move towards implementation. But back to AI, back to the technology. I mean, we kind of used this AI buzzword quite a bit already, but let's really start out with like what's going to power AI and what's going to make AI robust eventually is the data.
90%. So 90% of the data has been created in the last 2 years. That's explosion. We talk about data quality. So 68% of the number one barrier to operational progress is because of data quality, poor data quality. And then, of course, the hype that we all love as a technology company. You can't ignore the adoption that was achieved with ChatGPT in our consumer lives, right, in our personal lives. That's tremendous. We've never seen anything like that before, so we need to embrace that. However, there's a few challenges with this. The first one is, I don't know about you, but I get many notifications on my phone. When my garage goes up and down, when 16 packages come to my house from Amazon, of course, Outlook, emails, Teams chats, it's overwhelming. It's to the point where I pretty much ignore all of them. And that, I'm sure, just like your personal life, is no different. There's so many dashboards, as you're seeing this, alarm fatigue. And then because of it, there's this lack of insight that's holding us back, and talk about those barriers earlier. And then, of course, adoption is how are we getting these technologies adopted? So this probably looks like your world today. So most of you, when we talk about digital transformation, are focused very much on these dashboards. OEE dashboards, quality dashboards, root cause analysis dashboards. We have many, many, many dashboards. And we've spent a significant amount of time connecting our data to create these dashboards. However, every time we make a system change, we change an integration, we get a new question from maybe an executive, every single time we have to update these dashboards to try to get the insight that we're looking for. So, when you get that phone call, you're like, oh no, it's the boss, right? When you get that phone call and you're asked, what's our yield today? Typically, the people that we talk to is we have to go to 15 different dashboards, probably make a few phone calls, and then 4 or 6 hours go by, and we actually answer that question, and by then the answer is obsolete. So that's the world we live in today. So what I just described and what I talked about a little bit is this idea of poor quality. So again, I'm going to make sure you're engaged, you're not falling asleep. So how many out there feel like you're data rich but insight poor? Okay, we were at a conference last week. Annemarie, looks very similar, the response we got from that.
Yeah, usually many people seem to agree with it. What I found was interesting last week at the conference, actually somebody in the audience actually engaged and raised their hand and asked a question. Maybe we'll get to that later if we have time. But they were asking, like, what do you actually mean by insights? So actually I thought it was a great question because maybe sometimes we're all a little bit on that buzzword train, right? We're all talking about insights and maybe we all mean different things when we say insights. So I was thinking about maybe we rephrase and reframe that a little bit. We talked about with data chaos and really wanting to transition that into intelligence, into intelligent decision making. So now you could say the same thing. I mean, what is intelligence? So maybe you all think about what is the most intelligent system that you know, that you can think of. Any thoughts?
Phone?
Maybe a little hint. We all... Kitchen calendar, that's interesting. Good. Our people, yes, I think a great answer. I think, I mean, we all carry one of these systems with us. Yes, the brain, thank you. It's not our phone. I was trying to see what the answer was going to be. I think it's the brain. I think the brain is pretty exciting. So let's try to apply our brains to this question. Again, the boss is calling, what's our yield today? Or more importantly, why is our yield down today? Right? So maybe the what's our yield question, we could still answer from the dashboard. That might be easy to read. But when we go into root cause analyses often, why is our yield down today? There's so many different reasons. So as we apply our brain to this, let's try it together. We're also going a little bit into the brain and kind of seeing what the brain does. There's actually two systems in the brain. I mean, there's also a book out there about that by Daniel Kahneman. But so let's think about that. One approach we can take is we can answer this question kind of intuitively. So we can apply our gut feeling to it. And based on the experience we've gathered, we would probably maybe have a better or worse gut feeling. So that's one approach. And that's pretty fast, right? So maybe a thought pops to your mind. It's kind of like the alarms that pop up in our industrial systems, right? So it's really ingrained into our brain. That will probably get a quick answer to that question. Now that quick answer might not be the correct answer. That's how intuition works. That's why we also have another system in our brain where we can actually do deep analytical thinking and processing. And that's the same thing we could do in the industrial setting where we could basically leave the show for today and go back home. Or go back to our manufacturing site and run a few root cause analyses and do a few simulations. Now, the cool thing about our brain is our brain can actually connect both of these systems. There's the prefrontal cortex that can combine these two systems in the brain. And it can do that because it's all connected, because all of these different parts of our brain actually communicate to each other. And what that allows us to do is we can ask a question, it can process these different systems in the brain, and it gives us an answer. And the answer is both fast, intuitively, and it's also correct. So now we want to kind of achieve the same thing in manufacturing. We want to be fast. In engineering, I think especially, we talk about efficient engineering. We want to be fast in execution. We talked about how our automation systems are highly performant and highly reliable. And ultimately, we want to make the right decisions to continuously optimize our operations. So now as we apply this brain analogy to our manufacturing systems, it's about connecting all of them. It's about connecting engineering to execution, to operations, to make the right decision. And that's what we do in the digital thread, and specifically in the smart manufacturing digital thread.
So digital thread is a pretty common term now. What's important for us when we engage with our partners, our customers, is we define what smart manufacturing is. So we have a definition of that. Our customer, our partner has a definition of that. So the first thing we do is align. What you see here is a pretty high level example is how we define smart manufacturing. That's on purpose. So we start here. We talk through that. We also can go to level, what we call level 1, level 2. So we can get pretty deep into each one of these steps And the idea is understand their business process, understand the systems. In some cases, it could be Excel or other systems that they're using today, and most importantly, understand those integrations. So as we walk through this, we want to understand, so for instance, if you introduce a requirement, how does that requirement travel all the way through this digital thread? Does it get stuck somewhere? Is there barriers somewhere? So it's extremely important we understand that, we fix that so we can get that connected environment that Annemarie talked about. Most important in that discussion, so of course it's the systems that exist today. It's the systems that maybe we can introduce that make sense, that provides the value that they need for this integration. And then most importantly though, is how that data transforms or transcends from manufacturing concepts all the way down to optimization.
So now, because we have all this great data, maybe quick raise of hands, who of you has heard this great idea? Chris actually brought it up in the beginning. Now that we have all the great data, let's just sprinkle some AI on top to answer these questions. Who's heard these proposals maybe from management recently? Yeah, a few people, good, okay. I mean, I think it's quite actually comparable to this emotional response, right? It's the fast, or we think maybe that's the fast way to fix it. It's also emotional in the sense that it's often kind of fear-driven. So management would have seen from the competitor that they've done some fancy proof of concept with AI, and now we also got to sprinkle this AI on top and get like a fast improvement here to be able to answer these questions. Now, the challenge is if we just put some generative AI, just some large language model on top, most likely, just based on the chaotic data, the answer is not going to be right. So in order to get the right questions, we need to build more of a resilience layer around this digital thread and the data. We need to contextualize the data. We need to add a certain level of protection layer on what kind of data are we actually going to expose upwards to the AI, sometimes to the cloud, but also what kind of data actually would we write down as we aspire to eventually become somewhat autonomous in certain processes. We don't want for the AI to just write back all sorts of control parameters. And this AI, especially a generative AI, is basically concatenating words and numbers. So we do need to guardrail it with actual statistically and analytically correct root cause analyses, for example. And we could go on and on and on, right? We could also guardrail it with actual physically true simulation results. We could add more data, like recipe data, for example, and so on and so on. So that becomes a little bit overwhelming, right, as we flange on more and more and more. So then we also want to think about what is the concrete next step to take. And this is something we've done together with one of our customers, Borg Warner. We've done very well. So they started actually with a very concrete problem of having to understand across almost 90 sites globally, having to gain insights and transparency and intelligence over their energy use. And they had to transition, of course, from multiple heterogeneous siloed systems, from plant managers having to make decisions based on Excel tables, into actually getting these insights and getting this intelligence across multiple plants. So we connected over 70 plants globally and over 800 devices to ultimately reduce and follow their sustainability and CO2 reduction targets, reduce energy consumption by 8%, but also reduce the data collection efforts that it took to get there by 80%.
Thanks for that, Annemarie. I was proud to say I was a part of this pursuit team. A couple things you didn't mention. One of the reasons why we won is because our proposal had us doing this in 6 months. And the other people that were submitting their proposals were 2 or 3x that. And we did achieve this actually in 6 months. The other mantra as part of this account team is we kept saying every plant is not created equal. And we kept saying that because we kept saying, well, can't we just replicate one of these times? And we couldn't actually. But that was a challenge that we were faced with. As you could see, we got the results that we expected from that. So very proud of that pursuit and very proud to call them a customer and a partner. The next is we talk about the workforce. So again, tremendous opportunity to take that leap with the workforce that we already talked about in the beginning. However, with that, there's some things that we need to consider. Number one is this a new generation. Clearly, they have new expectations. There's a skill gap. So there's a skill gap that exists today. I think we all know that. But look at the number, it's pretty staggering. By 2030, that number is at least 5 million. There's some studies that it's greater than that actually say that. So we have to leverage this transformational technology to fill this gap. And then, of course, the rapid change. This is a really cool, I'm not sure the slide represents this, so maybe we got to change this, but this is a really cool stat. The way it used to be is you could go out and train your operator on new technology, and that operator was fine for about 7 years. Because of the way the technology is changing and transforming, that's less than 3 years now. So learning and development needs to be in your DNA, not just for people in the office, but definitely for people on the shop floor. So with that, comes challenges. First one is how do we attract this talent? How do we make sure we go get that? There's a gap out there that I just talked about. How do we go attract the talent? The next one is this turnover. And then, of course, you can see the number around retirement is around 27%. So quickly, which one of these is your number one concern? So number one, obviously, would be attraction. Number two, turnover. Number three, retirement. So I can see which one, biggest concern. Three, a lot of threes. It's pretty well, it's almost a third, a third, a third. But, you know, and we can have this argument, and actually there's happy hour at 4 or 5 o'clock, so let's have this argument at happy hour today. But the good news is there's salvation, that's what we're gonna talk about. So think about today, and I have a few of these at home, if you're early career, and you get excited about going to this really awesome industry called manufacturing. Think about today if you're going out there and you're applying for a job. And the first one you go to, kind of a dirty environment, they walk you up and say, here's the machine you're gonna be working with. Oh, by the way, this is paper instructions. I'm not sure if they're up to date, I'm not sure what version they are. Oh, and by the way, every now and again, you gotta walk over to this laptop over here, log in as factory one and just use Apple as a password, and you gotta log in a couple times at each one of your shifts and then come back. So that's your first interview. The second interview, you walk in, very clean environment. They hand you an iPad and said, here's everything you need to know to be successful in your role. And by the way, we consider you a technology specialist. Which job would you choose?
I think the answer's pretty clear, right? Are we waiting for that? But so now, speaking of hiring and going back to the question, so let's say we successfully attracted a new talent. Now we're gonna go back to our thumbs up, thumbs down exercise here. Who of you can see that thumbs up, that within the next year or two, we would also hire, in addition to our human worker, we would also hire an AI assistant or this industrial companion to work alongside with this worker. So thumbs up, within the next 1 or 2 years we see that. Thumbs kind of in the middle, like I'm not so sure yet if that's gonna come, and thumbs down, that's never gonna happen. So we see a few thumbs up, but okay, most people are kind of like, nah, not sure, but okay, yeah, we have a Siemens skewed data set again, I think, so the brainwash is also a little bit back. Yeah, I mean, we definitely think that, and we are working on pilot projects towards that, because we do believe that there is a tremendous opportunity out there to basically add a new hire with not a lot of experience, obviously, and leverage these industrial companions to instantly get new hires access to 20 years of knowledge. So now if we see this kind of control room scenario, for example, we can work alongside the industrial companion, access all the data, get answers to these questions on why is our yield down today. That's one thing, of course, but now you might think, I mean, that's great, so I can kind of have this monitoring and decision-making assistance. But the big challenge is actually that I might also still, I mean, ultimately, after all, we're still in automation. I might also actually still need to go down to the shop floor and adjust a piece of control logic, like maybe that's literally what my industrial companion just told me. So that's typically a challenge, right? We deal with pretty specific engineering tools. We still deal with pretty proprietary programming languages. But so now the next big leap that we're seeing here is we can actually have this engineering assistant that can help us generate the PLC logic and generate the HMI screens and generate the documentation. So we can ultimately reduce the time that it took to do such an engineering task from maybe 3 weeks for untrained personnel to just 3 minutes. So that's going to bring the brain back, and that's going to help us accelerate engineering and be fast in engineering. Now on the operations side, of course, we still need to get things right. So even after we updated the code, and of course we want to get this one right as well, there might still be some alarms popping up. And the other challenge that we typically see with alarms is that they're often not very descriptive, right? They're often quite cryptic. Often we don't know what to do with these alarms. So the other huge leap, the other big opportunity that we see to also retain talent is to make these alarms more descriptive and actually attach concrete action recommendation to these alarms. So we're going to help with everybody that kind of shared the number 2 category earlier in retaining talent, because we're actually making this interactive and we're making this an exciting place to work in because we know exactly what we're doing and we're kind of working alongside with Companion. So it's exciting, but as exciting as it gets, I mean, my time's kind of up, so my shift's actually over, Chris, so you can take over, and I'm kind of out of here for now.
Normally I'd get very nervous because I'd want to understand exactly what happened on that previous shift. But since I have all this cool technology, we learn about what happened, the parameter changes we made on the previous shift. If the temperature changes, we understand that we saw the same thing a week ago. So we learn what set points to use for that next shift. The system learns, it remembers, and we build on it shift over shift, day over day, week over week. And we continually leverage these lessons learned and keep improving that production that we talked about. So what we talked about is the importance and now the ability to first attract talent with this modern and intuitive technology. We talked about the importance of enabling. I talked about that stat from 7 years down to 3. So, and how do we enable? And Annemarie went through some of that. And then, of course, retaining that workforce is we want to make sure once we get that, we want to make sure we retain them and continue to make them better, continue to give them the latest and greatest technology. And then, of course, the importance of amplifying that. So allowing them and giving them the ability to be for this continuous learning and to get better and better and better. So one of the examples we want to use, one of the proof points we want to use, of course, we got to use Coca-Cola. I think I passed the headquarters on the way here. I know for sure it was the museum. So I want to make sure that we use this. We're very proud of this proof point, this customer example. Similar to Borg-Warner in the fact that it started with the sustainability initiative. So we were going after the KPIs. But since the number 1 goal for us was this OT integration and this connection that I talked about, since we did that very quickly, what we did with Coca-Cola is we scaled to OEE, we scaled to root cause analysis, and we gave that information, more importantly, to the worker, and we connected the worker, and because of that, we're able to get the production numbers you see here, so an increase of 4.2%. So very proud to be a part of that journey with Coca-Cola, and since we're in Atlanta, I thought that was pretty relevant to the group here. And if you want, we can go see it, maybe at lunchtime, we'll walk down the street and go see that. Okay, so we talked about data and AI, this opportunity for leaps. We just talked about the workforce and the attraction and retaining and enabling the workforce. Now we're going to talk about accelerating outcomes.
I think we have a panel coming up to this afternoon at 1 p.m. I think it's room C107, so please join us there also for more interactions, more questions. I loved the examples that you brought up and looking forward to discussing more later on, and maybe if we have a little bit more time towards the end of this session as well. So now, I mean, maybe what's going through your head, right, after you heard all of this, we talked about the call from the boss earlier on, right? So what if the boss calls tomorrow and asks the famous question that I'm sure many of us have heard before, right? Why haven't we implemented this yet? Typically, there's quite a few challenges that we face. I mean, starting with what Roland was talking about, right? Like, as we implement these new technologies, as we implement this edge computing platform, as we implement the data integrations, that might cause downtime, right? So how am I going to go about that? Of course, finance is going to have some concerns about the ROI. I think there's the IT, OT, often, unfortunately, still blame game, right, that Roland also mentioned. So one other additional thought to consider as we think about connecting it all and as we think about the digital thread is to take it all into the virtual world. what we can do in the virtual world is that we can validate these visual inspection algorithms, not only the field of view of the camera, but the actual output that the AI is going to give us and how we're going to integrate that into the robotic arm, into the reject system. We can actually go validate that motion control path that we just automatically generated with our engineering companion. Finance is going to get their ROI analyses. We talked about AI not replacing workers, but AI working alongside workers, so we can also simulate the humans in the manufacturing environments. And the great thing is we can simulate also SCADA level and control operations all the way down to the physics level of, for example, what kind of control parameters or how is a control parameter going to affect this filling, this bottling process. And as I said, as we generate PLC logic, we can validate that in the virtual world and bring it all together. But so now also that looks like a big task, right? So Chris, I think you're probably going to ask your question again on now what's the specific step that we could take, not only to implement this digital twin, but to implement this entire project. So why don't you walk us through the framework that we apply here?
First, I just want to take a minute and say that was awesome, Roland. And that was no rehearsal, so that was fantastic. Quick show of hands again. How many out there get extremely excited, so show of hands if it's a yes, get extremely excited when your organization says, I'm going to roll out a system to provide discipline, traceability, and accountability? How many out there? Come on, you're lying. That's exactly right, and the reason why I say it is because the way you implement is extremely important. We don't want to get into that decision paralysis. We want to take an opportunity, like Roland said, is once you prove it out in a pilot, how do we scale? So the first thing we want to do is, as we outline this vision, and we talk about this vision, and maybe it's this autonomous phase that we talked about early on in the presentation, it's extremely important we align on that vision, but more importantly, we align on the roadmap to get us to that vision. And with that roadmap comes what is the value we're going to see at every step of this journey together. So that's the first one, is we want to make sure we align on the vision and the roadmap. The next one that's critical is the system architecture. So we talked about this idea of a connected environment. The only way you get there is if you roll out the right architecture. So it's important that we align on that. We understand your systems, we understand your integrations. We put the right platforms in place so we can scale. We put the right platforms in place so it's open, so we can integrate some of these other systems as you introduce them into your organization. So it's critical that we get that architecture in place. And then, of course, the staged implementation. So what we learned long ago is the sooner we get the user or the operator engaged in our implementation, the better. So it's important that we have a staged implementation approach. It's important we have an agile approach, because you don't know what you don't know until you get it in your hands. So it's extremely important we have multiple iterations, we have multiple touch points, we have what we call quick wins. We want to get the technology out in your hands as fast as possible. We want to support that roadmap we put in place. So it's critical that we have this staged deployment. The last thing we want to do is create this really cool project. It takes 10 months until we show you the technology or deploy the technology. By then, your information's changed, your company's changed, there might be new leadership, and so that's why it's important we have these staged implementations. So what makes Siemens unique is we're a manufacturing company. We're not just a technology company, but we actually manufacture ourselves. And many years ago, we were faced with a challenge. So China came to market with a PLC that was a competition against our flagship PLC that we produced in one of our plants in Germany. So we were faced with a challenge. Do we make our plant more productive, or do we shut it down? So we, Siemens, embraced our own technology. What was also interesting about that journey is we understood the gaps because we're implementing it ourselves. So understood the gaps that we had, and we made those investments, we made those acquisitions. You can see how aggressive we are in the acquisitions, and it's because we're always trying to round out this digital twin, this idea of a digital enterprise. So we embraced the technology. We did achieve some of these results that you see here through this technology. We saved the plant, and most importantly, we saved 1,200 jobs at that particular facility. So again, I think what we call it is, what Cedric says is we drink our own champagne, I think is the terms that he uses. He's from France, so that's why he says that. But so the three areas, we're going to come all the way back. Again, we talk about this opportunity to leap. The three areas we discussed, again, say it with me, people, process, and technology. The first is this idea of a connected environment, a brain. We want to make sure when there's a question, we can process it and get decisions fast and accurate. The second one, again, is around the workforce. When it comes to the workforce, we want to make sure that we can attract the workforce, number one. That's important because of the skill gap we talked about. Number two, we want to make sure we enable that workforce and then retain that workforce, and most importantly, amplify that workforce. Allow them to be more productive every single time they show up to work. And then, of course, what I just talked about is how do we accelerate and get the outcomes that we're looking for, is following an implementation process that significantly reduces the risk of not achieving the results that we set out to begin with. So that's how we get the people, process, and technology. That's how we get this operational leap. But we started this whole conversation around this transformational technology, right, which is obviously an enabler behind all this. But maybe, Annemarie, you could take us home and tell us the why. Why is this important?
Exactly so. And what are, again, bringing it back to the steps, what are the specific steps we now can take and why do we take them? So as we walk out here, we all have to make the right decisions and we have to make the decisions fast. So let's bring it back to this. I think we can all agree with that. Boss might be calling. We need to get a fast answer, but it also has to be right. So in order to make the right decisions, I think we also heard from Roland, we need the right data. And we need the right data also at the right kind of resolution, right? So Roland kind of brought up the example when I have like MES data with maybe like a 1 second interlock cycle time. I often need data at like a millisecond rate. So we need the right execution platform. So we get the data fast so we can make the right decisions fast. But it's not just about insights. It's not just about the transparency. It's not just about monitoring. We also have to drive towards outcomes fast. And in order to get outcomes, we also talked about sometimes having to actually go in and update our systems. Maybe now working with the AI companion to deploy this new piece of PLC logic. And then that has to be fast and efficient in engineering. So now these are still quite a few steps. And we want to bring it back to these steps have to be connected. So as I derived what the right updates are, maybe I validated them virtually in a virtual environment. That's basically what brings me, what also expedites engineering, right? So I can actually go through a build, test, deploy kind of DevOps cycle, bring that to automation, and eventually have my, not just my piece of PLC code, but maybe also a packaged digital twin or a packaged simulation and executable digital twin deployed onto my execution platform, where I need the right resolution, I need the right performance. We need to get back to our actual control qualities on being reliable and being performant. And then as I execute all of these artifacts, that's going to ultimately feed more into the right data, into the proper data platform, which is going to close the loop and deliver me the right insights and help me make the right decisions and drive towards outcomes fast. So all of that means that it's all connected. It's connected across people, process, and technology, and it's connected across the digital thread. Thank you.
So first and foremost, I want to thank you because we put you to work. You participated quite a bit with all the questions. So thank you. Thank SBS. SBC is the internal meeting. It feels like an internal meeting, but SBS for giving us this opportunity. And most importantly, like I said, it was awesome, Roland. I just want to thank you. You couldn't have described it any better without a rehearsal, and that's just because that's your daily life. So thank you, Roland, for joining us on stage. I really, really appreciate it. So I look forward to seeing you at the Siemens booth and the 1 o'clock. I'm actually moderating this session, so I get a lot of fun. So I get to control the questions, which is pretty awesome. So maybe I'll let you talk about certain things, maybe not. For sure, Roland, you can do whatever you want.
Wow.
Thank you, everyone.